Hello friends, welcome to our YouTube channel Demo Rides. We hope you are well. Today we will continue our math series from the previous video. So let's learn together. In the previous video, we discussed the different types of number systems based on their basis. So new viewers are advised to watch our previous video. We give the link in the description bar. Today we are going to discuss the classifications of the decimal number system or the base 10th number system. Okay, we can classify the decimal number system based on their properties. We have a table here for your better understanding. You can pause the video and write down the table here. So what's in the table? The decimal number we can classify in two different numbers. One is real number and one is imaginary number. And the real number, we can classify these in rational and irrational number. And the rational number, we can classify into integer number and fractional number. And the integer numbers, we can classify into whole number and natural number. So what these things? What are the definitions of these number systems and how can they used in our daily basis math problems? Let's discuss. So what are the real numbers? First, the definition. The real numbers are any number that we can represent in the number line. All arithmetic operations are done with real numbers. A real number can be positive or negative. So it's not necessarily positive or only negative. It can be positive or negative. Example, -6, -8, 10, 130, etc. So the real numbers are any number that we can represent in number line. We can do arithmetic operations with it, and a real number can be positive or negative. Now, imaginary number. The imaginary number are the unreal numbers. We cannot express these numbers with the number line. Imaginary numbers are used to represent the complex number. So, there is a basic difference between imaginary number and the real number, that we can represent the real number in number line, but we cannot express these numbers, these imaginary numbers, with the number line. And imaginary numbers are mainly used to represent the complex number. Example of imaginary number is root over -5, root over -7, etc. Anything in root with a minus sign is an imaginary number. Okay. Now, rational number. Rational numbers are in the P by Q form. Okay. What is P by Q? The P by Q are the integers. So numbers that are in P by Q form are rational number. But there is an important point that this Q is not equal to 0 always. Okay. If the Q is equal to 0, it will be not an rational number. But if the Q is not equal to 0, we can say that the number is a rational number. And if we represent the number in P by Q form. So let us look at the example. Here 0.25 equals to 25 by 100. We can write this. Okay. So this 0.25 we can represent this in 25 by 100. This 25 by 100 is represent the P by Q, and the Q, which is here 100, is not equals to 0. That's why this 0.25 is satisfied these two conditions, that this can be represented in P by Q form and the Q is not equal to 0. That's why we can say this 0.25 is a rational number. Same as if 0.016, we can represent it 16 by 1000. Here we can represent this number in p by q form, and the q, which is 1000, is not equal to 0. So we can say that this 0.016 number is a rational number. Now, what is a irrational number? Numbers that are not in the p by q form are irrational numbers. Okay, here also the q is not equal to 0 and p by q are the integers, but what, we can't represent these irrational numbers in p by q form. Okay, let us take an example: root over 5, root over 7, pi. Okay, we can't represent these things in p by q form. That's why we call these numbers are irrational numbers. Okay, now integer number. Integer numbers are the part of the rational number. Look, integer numbers are the part of the rational numbers. Okay, definition of integer numbers. Integer numbers, all counting numbers, zero and negative counting numbers are part of integer numbers. Okay, so all the counting numbers, whether it is negative or positive, includes 0, are part of the integer number. So in the example we can say 0, 1, 2, 3 and so on, and -1, 2, -3 and so on. All of these counting numbers are integer numbers. Okay, now whole number. Look at the table. The whole number is a part of integer number. See, this table is very important to remember all these numbers. Okay, so pause the video and write it now. So what is whole number? Whole numbers are part of integer numbers. All counting numbers including 0 are whole numbers. This is the main point, that whole number includes 0. Whole number includes 0. So in the example, repeat with me, the whole numbers starts from 0 and all the counting numbers in it. So 0, 1, 2, 3, repeat with me again, 0, 1, 2, 3, all these numbers are whole numbers. What are the natural numbers? All the counting number except 0 are the natural numbers. Okay, this is the main point here, except 0, except 0. Repeat with me, all the counting numbers except 0 are the natural numbers. All the counting number except 0 are the natural numbers. So what is the basic difference between whole number and natural number? Whole number including 0 and natural numbers are excluding 0. Okay, so example, the natural number starts from 1. So 1, 2, 3, 4 and so on are the natural number. Okay, sorry. What are the fractional number? What are the fractional number? The fractional numbers are also part of rational number. You can see from the table, the fractional number are the part of rational number. Okay, so what is the definition? Fractional numbers are also part of the rational number. In fractional number, this is the main point. In fractional number, the q is not equal to 0. Where this q came from? This q came from this b by q. Okay, this q is not equals to 1 in fractional number. Okay, if this condition is satisfied, for any number, any rational number, then we can say that this is a fractional number. Okay, now we have three examples here. First one is 5 by 8, second one is 14 by 3, and the third one is 3 and a 5 by 6. Okay, look here, the 5 is less than 8. The 5 is less than 8. So we can say this P is less than Q. If in a fraction the P is less than Q, we can say that this fractional number is a proper fraction. Okay, here 14 by 3, the P is greater than Q. The P is greater than Q. That's why we can say this is an improper fractional number. Okay, and here 3 and a 5 by 6, we have an integer part 3 and a fractional part 5 by 6. So we can say that this is a mixed fractional number. So we can also classify the fractional number into these three fractional numbers. Okay, now we are going to discuss about some other number. Okay, other types of numbers. Even numbers. If any number is divisible by 2, if any number is divisible by 2 is called an even number, like 2, 4, 6, 8, etc. Look, this 2, this 4, this 6, this 8 or 10 or 12 all are divisible by 2. Okay, so we can say that these numbers are even numbers. So what are the odd numbers? Odd numbers are the the opposite of even numbers. The odd numbers are the opposite of even numbers. If a number is not divisible by 2, is called an odd number. Example 3, 5, 7 or 9 or 11. You cannot divide these numbers with 2. Okay, these numbers are not divisible by 2. So we can say that these numbers are odd numbers. What are the prime numbers? If a number is divisible by 1 and itself only, then the number is called a prime number. Okay, if a number is divisible by 1 and itself only, then the number is called a prime number. Look, 2, 3, 5, 7, 11, 19, 23. All these numbers are divisible by 1 and the number only. Okay, 2 is divisible by 1 and 2 only. 11 is divisible by 1 and 11 only. That's why these numbers are called the prime numbers. Okay, here is a quick note that there are 25 prime numbers between 1 to 100. This is very important for competitive examination. Okay, there are 25 prime numbers between 1 to 100. Now, composite numbers. The natural numbers which are not prime are called composite numbers. The natural numbers which are not prime are called composite numbers. Means the composite numbers has more than two factors which are 1 and itself only and other factors in it. Like here 2 and 3 are the two factors of 6. And we know that 6 is divisible by 1 and 6 also, and 2 and 3 also. So if the number is divisible by 1 and itself and other factors, then we can say that the number is a composite number. Okay, Now, what are the co-prime numbers? If the HCF of two numbers is 1, then the numbers both are called co-prime to each other. Okay. If the HCF, what is HCF? The highest common factors. If the highest common factors of two numbers is 1, then the numbers both are called co-prime to each other. Like 2 and 3, 7 and 11. In 2 and 3, the HCF of 2 and 3 is 1. So we can call these 2 and 3 are co-prime to each other. Now, Armstrong number. Definition. An Armstrong number is a number that is sum of its digits, each raised to the power of the number of digits. What does it mean? Let us take an example. We have here 371, which is a 3-digit number. Now, because it's a 3-digit number, we sum up each digit with the power of 3. Now, if we calculate the result here, we can see the resultant number is same as the original number. Okay. You can calculate also your own that the resultant number is same as the original number. That's why we can say this 371 is an Armstrong number. Now, if we take a 4-digit number, suppose we take here 1634. Now, because it's a 4-digit number, we have to sum up each digit with the power of 4. Now, if we calculate the resultant and sum up, then we can see the resultant number is same as the original number. Okay, the resultant number will be same as the original number. Now, palindrome number. Okay, a definition first. A palindrome number is one which is read the same as in reverse. If we write a palindrome number in reverse, we get the resultant number same as the original number. Like if we write the 585 in the reverse order, we get the result 585 itself. Okay, so if we write the palindrome number in reverse order, we get the original number only. Okay, so here is a quick note. There is a number 22 in 10 base. Okay, there is a number 22 in 10 base, and you can see that this 22 is a palindrome. But if we converted it into the binary number, we have this number. Okay, 10110 with a base 2, because it's a binary number. I converted this 22 in the binary form. That's why we get the 10110. Okay, this number, which is not a palindrome number. Look, this binary number is not a palindrome number. So we can say that if any number is palindrome in one base, it is not necessarily palindrome in other bases. Okay, if 22 is palindrome in decimal number system, it is not necessarily it will be palindrome number in the binary system. Okay, so that's all for today. We hope this video is helpful to you guys. If you do like this video, please press the like button and do comment all your doubts in the comment section. We will try to clear all your doubts. For more updates, hit the subscribe button and press the bell icon for video notifications. Please share our video to support us. Stay home, stay safe, and follow the government rules. Thank you.